Homework number 12. The first 4 questions ask you to find the slope or rate of change when given 2 points. We're going to use this slope formula right up here on the left-hand side. So the easiest thing for most students to do is to label their points first. Each point is a pair of x and y values. So if this is the first point, these would be x1 and y1. And the second point would be 2 and y2. This will help you to put the parts in the right places. Every ratio starts as a giant subtraction fraction. And now we're going to put our y2, and then we're going to put our y1. And then our x2 in the denominator, and our x1 in the denominator. Now be careful. Some numbers have a negative sign, but the formula also has a subtraction sign. So make sure you're writing both. Now you're going to pick up your calculator and compute. Most of you have a fraction button on your calculator, and you can open it and put the entire math problem in at one time, just like this. And it will give you your answer in simplest form. Let's do the next problem. Again, I'm going to label my x1 and y1 and my x2 and y2s. Set up my giant subtraction fraction and then compute y2 minus y1 and x2 minus x1. When I type this fraction into my calculator, I get an error message. We get an error message because the denominator is 0. And anytime the denominator is 0, our fraction is undefined. Number 3, x1 and y1, x2 and y2. Giant subtraction fraction, y minus y over x minus x. Now we can compute. And this time, we got a 0 in the numerator. A 0 in the numerator results in a slope of 0. Last one, x1 and y1, x2 and y2. Giant subtraction fraction, y minus y over x minus x. This one gives us negative 1 over 8. Next section, write the equation of the line shown in the graph in slope-intercept form. So to write the equation of a line, you need at least 2 points. I've gone and highlighted in red a few perfect corner points. I always need to identify the y-intercept, and then I need to calculate a slope triangle. So from one point to another point, I have a rise of negative 1 and a run of 3. So that means my sentence will have a slope of negative 1/3, which makes sense because the line is going downhill, and a y-intercept of 0. That's a correct answer, but so is this. Question number 6. I found my y-intercept. Now I'm going to find some other perfect corner points. I'm going to draw that slope triangle. Again, it's going downhill 1 unit and running 4. So my slope will be negative 1/4 x, but my y-intercept this time was at positive 1. Next problem. I have a y-intercept at negative 1, and it looks like my slope triangle is down 3 and run of 2. It gives me a slope of negative 3/2 and a y-intercept of negative 1. The last part of this box asks you to write an equation for the table shown. an equation in slope-intercept form looks like this. So we need to calculate or determine the y-intercept and the rate of change. Sometimes you can find the y-intercept in the table when the x is 0. So that means our y-intercept is going to be 5. And now to calculate our rate of change, we need to know the delta y and the delta x. You can choose any 2 points from the table you like. So I'm going to calculate the change in the y right here. It's going up 2. And for the same points, the x's are going up 1. So that means our rate of change is 2 over 1, also known as just 2. Now I can put these values into my slope-intercept form equation. Question number 9 does not have an x with a value of 0. So therefore I can't take a shortcut with the y-intercept. But I can still find the rate of change. So I'm going to look for a pattern between any 2 points that I want. So it looks like the change in y here is up 3. And the change in x here is up 2. So the rate of change is 3 over 2. That's our m value. Now in order to find our b value, we're going to choose 1 point from the table. I'll choose this one here. And those will represent the x and the y values. And now I'm going to take all 3 of these values and substitute them in to the y equals mx plus b formula so I can determine b. So y equals mx plus b is the formula. But I'm going to erase y and replace it with a 5. I'm going to erase m and replace it with a 3/2. And I'm going to erase x and replace it with a 2. Now I have a sentence with only one letter, and I can simplify it to solve for b. So the first thing I'm going to do is I'm going to multiply 3/2 times 2. That's going to give me 5 equals 6 divided by 2 is 3. And now, in order to get b alone, all I have to do is subtract 3 from both sides. And that tells me that b is equal to 2. Now I have the 2 values that I need, m and b. So y is equal to 3/2 x, and positive 2 is b. The next section asks us to solve these equations. Now, do you notice something right away about question 10? I notice that the left and the right sides are a perfect match. That means there are infinite solutions. But another way you could solve this is to subtract 5x from both sides and see that we have no x's left, but we have a true statement. Now, when something is a true statement, that's infinite solutions. If you had added 9 first to each side, you could still get the same answer, right? A matching left or right side. Or even if you subtracted 5x, you'll still get a true response. The left and the right side are equal. Or maybe you decided to divide by 5. Again, you get an equal response on both sides. Infinite solutions. Number 11, we need to distribute. And now we need to use the addition property of equality to get our constants on the same side. And now we use the division property of equality on the coefficient to isolate the variable x. Last one. Do you notice it? It's almost a perfect match. The variable terms match, but the constants do not. And anytime that happens, it has no solution. But here's another way you can look at it. If I subtract 7x from both sides, I get a statement that is false. And anytime you have a false statement where there's an equal sign between a single value, it's no solution. This section asks you to graph the equations on the grid provided. We're going to start graphing by putting a point at our y-intercept. And then we're going to follow the directions of the slope. Now, slope is always a fraction. So if it's not a fraction, you give it a denominator of 1. So we have a y-intercept of 4 and a slope of 2 over 1. Now when we started our y-intercept, we can't rise 2 because we run out of graph space. So what we're going to do is we're going to write equivalent fraction. Instead of positive 2 and positive 1, we're going to switch both their signs. So down 2, run 1. Negative 2, negative 2, negative 1. Negative 2, negative 1. Negative 2, negative 1. And there's our equation. Now let's do a common sense check. Is the graph increasing positively? Yes. Is the graph crossing the y-axis at 4? Yes. Now for number 14. I need a y-intercept value, and if it's not there, then the only invisible addend is 0. So that means we cross the y-axis at 0. Don't forget the slope has to be a fraction. If it doesn't have a denominator, put a 1 underneath. We rise negative 3, we run positive 1. Now if you can't go again, try reversing the order of your fraction by changing everybody's signs. So this time, I'm going to rise 3, but run negative 1. And that will help me to draw the other half of my line. Now let's do a common sense check. Does it pass through the origin? Does it go downhill? Yes. Question number 15 is a tricky question because you only have one variable. And when you only have one variable, you have a special type of slope. Because this has an x only, that means we will only touch the x-axis, and we will only touch it at this value, negative 1. So that means my slope is undefined. X is always negative 1. No matter what y I pick, x is always negative 1. The last box asks you to compare the rates of change. Which function has a greater rate of change? Well, when you have an equation, you just need to use your eyeballs. The rate of change is 5/4. But when you have a table, you need to pick 2 points. You need to set up your giant subtraction fraction, and you need to put those points into this formula. And then you pick up a calculator, and you compute. So I'm going to open my fraction button here. 4.5 minus 3 over 15 minus 10. I get 0.3. Now if I want to convert that to a decimal or a fraction, I can use that converting button on my calculator. For you guys, you have to press the green button first. And for me, I'm going to get 3/10. So 3/10, or I can leave it as 0.3. Now in order to compare these values, they either both need to be fractions or they both need to be decimals. So if you don't know what 5/4 is as a decimal, you take 5 and you divide it by 4 using the division button. And we're going to get 1.25. This might be easier for some of you to compare. 1.25 is definitely greater than 0.3. So function A has a greater rate of change because 5/4 is greater than 3/10. And that concludes homework number 12.